Okay, yeah. Hi, everyone. So, in this session, we are going to discuss about event-driven architecture with the help of SQS. So, majorly, we are going to discuss about SQS uh, by default, the core features, core components, and then the later another part of the session, we are going to do some demo with S3 events and then how to handle the S3 events with SQS and how to process the events with Lambda. So that we are going to discuss about in this session. Okay, so for now, let's discuss about SQS core components. So what is SQS? SQS is a simple queue service from AWS. So we can store our messages in that queue. Okay, so whenever the message producer, they will send their messages events to the queue. Okay, so the consumers, they can get the messages from the queue. Basically, it just decouple uh, the process, so it's also buffer the messages. It basically decouple the data process between one service to another service, so it's also buffer the messages, so to avoid the data loss. Okay, so that is the purpose of using queue system. Okay, so it's a kind of temporary storage. It locates the messages that need to be processed asynchronously. Okay, so and then majorly it decouples the components of distributed system, buffering the request and handling asynchronous tasks. It's actually doing it. So another component is we can tell the messages. Message is just nothing but our data, our information, which need to be processed from one service to another service. Okay, so it's a kind of key value pair. Okay, the data is kind of will be stored into the key value pair. Up to 256 kp size of data we can insert into the queue. For the particular message, it can be up to 256 kb. Okay, so yeah, we when we talk about the queue, we need a producer and then consumers we need. So the producers are, it can be any kind of services, the Lambda or our applications, our web applications, or some other AWS services, so that it can be anything. So it will send the events to SQS queue. Okay, so consumers are also, it can be anything like any AWS services or any applications, it can be anything. So it will get the messages from uh, SQS queue. Okay, so and then we can tell there is one of the feature is called visibility timeout. Okay, so visibility timeouts is a kind of period of time during the which message is invisible to other consumer. For example, if particular message is being processed by some other consumers, so the particular message, it will be it's not available to some other messages, to avoid processing the duplicate message, same message. So that's the reasons. So it has invisibility timeouts also, we can set it out. And then it has we can set up dead letter queue. So dead letter queue concept is when the particular message is not being processed, not being transferred to some other consumers, it can be sent to some other backup queues. Okay, so after the period of over the period of time, we can take that failed processing, failed messages, we can reprocess it again. That is the purpose we can do it. Okay, so to handle the failures, so debugging the issue, prevent the messages loss, that's the purpose of using dead letter queue here. So the next one, the message retention. So message retention means how long the message can be stored into the queue. Okay, so default it's a 4 days. Okay, the message will be available in the queue. Okay, so if you don't delete the messages, if your consumers don't delete the messages from the queue, message will be available for 4 days by default. Otherwise we can set the range from 1 minute to 14 days. Okay, that's also we can set it. Okay, so another feature is it has message deduplications. Okay, to avoid the message, the same message should be add the same message in the queue, we can avoid it by using deduplications. So deduplications, we can provide the ID to our messages based on that for each messages. So based on the ID, the queue, so we have to use, specifically we have to use uh first in first out queues, we have to use it. Okay, so in that queue it will check that messages order. Okay, so and then if the same ID it's exists, and then it will remove that message from that queue. So that is the purpose of using message deduplications. Okay, so and then message grouping also we can do that. So first in first out queues allow messages to be grouped by using message group ID, ensuring message with the same ID are processed in the same order. So that the purpose of the the processing order of processing the messages also we can use. Message grouping features also we can use, which is available only in first out queues. Okay. So the next one, the queue policies. So queue policies just like access control policies, which consumer can send the messages, which publisher can send the messages, and then um which consumers can use the messages. So in account level, IAM role level, we can restrict to access the queue. So that is the purpose. And then there is a mechanism to retrieve the messages from the queue, which is they are calling long pooling and the short pooling. Long pooling is you are just don't close the connections between your queue and consumers. Okay, so you are still open your connections should still exist for some amount of time. Okay, so a method where consumer waits for a specified time before returning the response if no messages are available in the queue. Okay, that is called uh, long pooling. Long pooling is your connection still exists for some amount of time. Okay, when the message is available, arrives in the queue, it will processed. So and then until unless you made a connections, okay, and then if message does didn't exist, you are not closing the connection between your consumer and then queue. So that is called long pooling. Short pooling is a kind of the same, but you are just make the connection between your consumer from connection between your consumer and a queue. Okay, if the messages exist, you will retrieve it. If the message is not exist, you will just return the some null value or no message. Uh, no message is available in the queue. That is, you are just close the connection within the fraction of like the when connection is exist. Okay, so that is the difference between long pooling and short pooling. Okay, so and then we can do some batch operation. Instead of every time you are sending the message and receiving the message, for each you are making the AP calls with your queues for each messages or each message you receive. So instead you can just collect all the messages. You can do some batch operation, batch execute. So bulk upload, bulk receive. So that also you can do it. Okay, and then the delay queues also, like the sending the messages to the consumers. So you can make the delay after 15 minutes, after some amount of time, you can send the messages to queue. That's also you can do it. Okay, the delivery delay, individual message delay, that's also you can do it. And then the encryption wise, the message transfers, everything is happen in the fly. They are using SSL. Okay, in the transit, uh, and then at the rest the messages are everything is encrypted. Okay, so by AWS itself, it can generate the encryption key for SQS. It can do it, but if you want to make your own keys also, that's also possible with AWS KMS service. Okay, that's also you can do it. And then for a monitoring and logging purpose, so you can enable CloudWatch to track the performance and health of your SQS queues. Okay, so and then if any issues is there, you can track it, and you can monitor the performance of your queues also. You can do that. And then the number of messages sent, received, and deleted, that's also you can um, progress it. Okay, so the next one, yeah, this is all about our AWS SQS queue, the basic components. So in the now we are moving to the next demo part. In this demo part, we are going to build a S3 event-driven architecture with the S3, SQS, and Lambda. Okay, so when user uploaded any files to orders folder, okay, so S3 will trigger some events. It just events means is what file is uploaded, in which directory it's uploaded, which path it's uploaded. That the events will be sent to the SQS. Okay, SQS queue, we are using standard SQS queue. We are going to create it. So SQS queue, it will store the events in the queue, and then Lambda will get the messages from the queue, and then it will process it. It just display the messages. That's it. So that is what we are going to do it in the demo session. So now let's share my screen again. Yeah. So now let's talk about the AWS CDK code. So here, line number 29, we are creating the processing bucket, S3 bucket, we are creating it. Okay, and line number 34, we are creating it. Queue, SQS queue, we are creating it, and visibility timeout, we are setting it for a 300 seconds. We are setting it, and then we are creating the Lambda to process the SQS uh, messages. Okay, and then here we are adding the bucket event. Okay, so when the uh, file is uploaded, object is created under the orders folder. It will send the events to queue. Okay, SQS queue is my destination, and then I'm subscribing the Lambda to SQS queue. So Lambda should receive some event from SQS queue, right? So we are adding the Lambda to the subscriber consumer to the SQS queue. Okay, and then I'm grant the consume permission for a processing Lambda, and then the resource policies also I am adding it. So now S3 can send the events to SQS. So that permission I'm sending to my queue. I'm adding it. So that's all about the CDK code. Now let's check the Lambda code. Okay. So this is nothing, just I'm creating the structure of how my S3 message should look like. Okay, so the records object should be there in under the S3. We can, so the bucket name and object, everything we can get it. Okay, so this is our main function, is a entry function. Okay, so it will trigger the handler function. It will call the handler function, and then it will get the events from SQS. Okay, and the SQS message, the body, we will get it, and then we are just unmarceling. We are getting the message, and then JSON format we are getting. We are converting into the struct Golang struct format. We are converting into it. We are just mapping with a JSON structure to Golang J struct. Okay, structure, Golang object structure, and then we are get receiving the events, S3 events, and then we are just displaying it. So that is what we are doing it actually now. So now let's deploy the changes. CDK, since it will create the CloudFormation code for my CDK code. CDK deploy. So just telling what are the resources going to deploy. So now resources are deployed. Now let's share my screen to AWS console. I hope the screen is visible. Yeah. So now let's go to the AWS. Let's check the S3. So we can see processing bucket should be created. Yes, it's created. It's empty now. And then we should see queue and Lambda function also we should see. Yeah. queue is being created. Lambda trigger. So we can see one Lambda trigger is there, and then function also being created. So it should subscribe SQS. Okay, so it's done. So now let's create the order folder and upload the file. Orders. Under the orders folder, let's upload the file. So yeah, file is being uploaded now. So now let's go and check the events like Lambda. So yeah, this is the latest message 1646. Yeah. So let's open that. So here we can see so the S3 events, SQS message body, and S3 message we are getting it, and then we are getting it like the files, which files we added. Yes, this is what it is, the file uploaded, and then the size of the files, everything we can see. Okay. Yeah, that's it. That's all about this session. So this is how we have to configure our like a S3 events with SQS and process the S3 events in Lambda. So this is how we have to do it. Okay. So the advantages of using this queue is the message uh, they can maintain in the order. Okay, that's also we can do it. Okay, so it's also supporting it. It's also supporting it. Deduplications, message grouping, everything it's supporting it. So yeah, that's it. That's all about the this session. So I this code also available in GitHub. The same GitHub you can see S3 SNS SQS Lambda. Okay, S3 SQS Lambda. So the code, everything is available. You can just go through it. So yeah, that's it. That's all about this session. Okay, so we will see you in the next session, guys. Yeah, thanks everyone.